Hi everyone. In this video I'm going to work a few normal probability problems, first using the normal table and then using the Rossman-Chance Applet. The first problem asks you to find the percentage of the standard normal distribution that corresponds to the region where z is less than 2.12. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. It's also called the z-curve. So this curve is also what's used for the z-table. I think it's best to find a picture for this. What we're asking is the percentage of the normal curve that falls less than a z-score of 2.12. To find that value, we need to go to the normal table. First find a z-score of 2.12. To the nearest tenth, and this first column is a column of tenths, we find 2.1. Then the hundredth value is 2.12, so 0.02. So we go 2.1 and a hundredth value of 0.02. That gives me a probability of 0.4838, or a percentage of 48.3%. Remember that on this normal curve we're using, the values in the table give you the percent that fall between a z-score and the mean. It's this blue region. Returning to the picture, what we know is that from the table, 48.3% of the normal curve falls between a z-score of 2.12 and the mean of 0. But 50% of the normal curve falls less than the mean. So the answer to this question, we have to find the total red region, so let's add the two values. 0.5 plus 0.4830 is 0.9830, or 98.3% of the standard normal curve, or the standard normal model, falls less than a z-score of 2.12. The second problem is just a slight variation of the first. What percent of the standard normal distribution, or standard normal curve, is found in the region where z is less than negative 1.48? The primary difference here is that we have a z-score that's negative. Remember that negative z-scores are those that are less than the mean. So, obtaining a picture of this, which I think is always a good idea, we have a z-score of negative 1.48, which is less than the mean. We want to find the percentage of the normal curve that's less than a z-score of negative 1.48. So it's the red region in the picture below. Again, going to the normal table, remember that this table has no values that are negative. So instead of, we can't look up negative 1.48, so we look up 1.48. The nearest tenth, we have 1.4. The hundredths value is 0.08. So we have 1.408. That gives us a probability of 0.4306. Note that that says that the value, the percent of the normal curve that falls between a z-score of 1.48 and the mean is 0.4306, or 43.06% of the curve falls between the mean and a z-score of 1.48. Since the normal curve is symmetric, that also means that 43.06 falls between a z-score of negative 1.48 and the mean. Okay, returning to the picture, what we know is that 43.06% of the normal curve falls between the mean and a z-score of negative 1.48. But we want this red region. What we know is that 50% of the curve falls less than the mean. So obtain the red region, subtract 0.4306 from 50%. So 0.5, which is 50%, minus 0.4306 is 0.0694, or 6.94% of the normal curve, the standard normal curve, falls less than a z-score of negative 1.48. The final problem we'll work using the table is called a backwards normal problem. It's where I give you the percentage and you have to find the z-score. So in this case, 91.6% of the standard normal curve, or the normal curve, corresponds to a region where z is greater than a. So in other words, 91.6% falls greater than a score of a. I knew that a was somewhere below the mean because I know that 50% of the values fall greater than the mean. That means 91.6% means it has to be the value, the z-score I'm looking for, has to be less than the mean because it's 50% plus something else. Now, to do this problem, we have to find that something else. So in this case, we know that 91.6% of the normal curve falls greater than our target value of a. Okay, 91.6% is 0.9160. But 50% of the mean of the normal curve falls greater than the mean. So the percent that falls in the region between a and the mean, well, we know that 91.6% falls greater than a, but 50% falls greater than mean, so I subtract. 91.6 minus 50% is 0.4160. Now, go to the normal table, and what we want to do is we want to look at the probabilities. The probabilities are the values in the table itself. So what I first want to do is find the closest thing I can to 0.416. Notice it's right there. That is the closest probability to 0.416. The reason I look at 0.416 because I want to look up what falls between the mean and the z-score. Now, finding the z-score that corresponds to 0.416, the tenth is 1.3, a hundredth is 0.08, so a z-score of 1.38 corresponds to a probability of 0.416. Now that's to the closest value to 0.416. Now, returning to the problem, we know that a z-score of negative 1.38 corresponds to a probability of this region of 0.416, or a total value of 91.6%, or 0.916. So the answer to our question, approximately 91.6% of the standard normal distribution is greater than the z value of negative 1.38. Now, let's work these same problems using the Rossman-Chance Applet. Here are the problems themselves. The same problems. Let's work them one at a time. What percent of the standard normal distribution corresponds to the region where z is less than 2.12? Bringing up the applet, what we know is that for the normal distribution, standard normal, the mean is 0 and the standard deviation of 1, so we don't need to change that. We want to find a score, a z-score, which is less than, so I toggle this, make sure this gray is less than 2.12. The z-score, okay, is 2.12, so the applet suggests that 98.3%, or 0.9830, of the standard normal curve falls less than a z-score of 2.12. Supposing I wanted to find the percent that falls greater than 2.12, all I have to do is click on this greater than and less than button. That would say that 0.0179% of the curve falls greater than a z value of, 2.12. 0.0170. Okay, let's look back at the second question. What percent of the standard normal distribution is found in the region where z is less than 1.48? Again, returning to the Rossman-Chance Applet, It's still using the standard normal curve, so the mean is 0 and the standard deviation is 1. The z-score in our case is negative 1.48. We want to find the region that is less than negative 1.48. So the applet states that 0.0694 or 6.94% of the normal curve, the standard normal curve, falls less than a z-score of negative 1.48. The final problem says 91.6% of the standard normal curve or standard normal model is in the region where z is greater than a. What's the value of a? So, returning to the applet, we know we want to find the value, the z value, so that 91.6% of the curve is greater than the z value we're looking for. So what I want to do is enter the probability, 0.9160 or 91.6%. That states, this problem, the applet states rather, that the z-score is negative 1.38. So in other words, 91.6% of the standard normal curve, or the normal curve, falls greater than a z-score of negative 1.38. And that's our answer.